Hey guys, this is Mrs. Hardman, and this is Advanced Math Factoring. Before we jump into Unit 2, we're going to do a Unit 1, like Part B. A couple of things we need to review that we just need to do before we jump into Unit 2. And so today we're going to look at factoring. So in algebra, hopefully you remember that when you multiply two numbers, those two numbers are called factors. And your final number there, your final answer that it's equal to, is a product. So every product has factors. Every product, every number has things that you can multiply to get that number. So like number 6, for example, we know the factors of 6 are 1 and 6 and 2 and 3. I can multiply 1 times 6 and 2 times 3. I know the factors of 10 are 1 and 10. And 2 and 5. Those are the things I can multiply, the factors I can multiply to get 10. I know the factors of 20 are 1 and 20, 2 and 10, 4 and 5. So every product, every number has some factors to it. You should be able to list factors of just plain numbers. Before we get into factoring polynomials, you've got to be able to do that. When we did the distributive property, what we were doing was multiplying factors. So if we did 2 times 3 plus 4, we distributed those factors and we said that 2 times 3 plus 2 times 4, multiplying those factors, would get us to 6 plus 8, which is 14. Or we could have combined those factors here at the beginning and just have done 2 times 7, which is also 14. So the distributive property is multiplying factors. Every number has factors, and you should be able to list the factors of a given number. Beyond just numbers, polynomial equations or expressions also have factors, like x squared plus 4x plus 3. X plus 3 and x plus 1, when we multiply those using FOIL, we get x squared plus 4x plus 3. If we were to work in reverse and go from the polynomial equation back to our two binomial expressions here, these would be our two factors, x plus 3 and x plus 1. And that reversal process is what we're going to look at today. That reversal process, or going from something that's already been multiplied and undoing it and pulling out the factors, is called factoring. Depending on what book you're using or what resources you find online, you might also see it referred to as factorizing in the UK. And this is the process of finding the factors. Basically, we're finding out what to multiply together to get the expression. So if my expression has a 4 in it, I know I had to multiply somewhere in there either a 1 and a 4 or a 2 and a 2 to get to that 4. So we're working backwards. It's like splitting an expression into a multiplication of simpler expressions. Let's take a look at what this looks at. So in the expression 2y plus 6, the first thing that we're going to do is think about what factors they have in common. Let me see if I can switch colors, and let's list some factors here. So the factors of 2y are 1, 2, and y. And there are no other factors to get 2 and y. The factors of 6 are 1 and 6, 2 and 3. The first thing I'm going to do is look for what their common factor is, and they both have a 2. So I'm going to pull that out and place it outside a set of parentheses, which you see right here. What remains in the parentheses is what's left when I remove that common factor. So when I remove that 2, what I'm left with is 1y. And when I remove the 2 from here, what I'm left with is the 3. Okay, the 1 and the 6 won't count because I'm doing the 2 times 3 factorization to get 6, not the 1 times 6. When we pull out the 2 and what's left is the y and the 3, we can say that it has been factored into 2 and y plus 3. To check our work and make sure we factored it correctly, we can redistribute, and we find out that we get 2y plus 6 when we distribute. That tells us that we have factored correctly. So factoring is the reverse of distributing. It's pulling out any common factors. In the previous example, we saw that 2y and 6 had a common factor of 2, but in order to factor properly, we have to make sure that we have the highest common factor pulled out, including any variables. So let's take a look at 3y squared plus 12y. We know that 3 and 12 have a common factor of 3. That's their greatest common factor. They also have a common factor of 1, but 3 is greater than 1. So we could pull out just the 3, but that would leave us y squared plus 4y in parentheses. And I see that this has a y term and this has a y term, so we know that we can do better. 3y squared and 12y also share the variable y. So together, they both share a 3 times a y. We can pull that out outside of our expression, and what that leaves us with is 1y in the first term and a 4 that was originally in that second term. Again, if I do the distributive property here and multiply that back out, I get 3y squared plus 12y, which was my original expression. So I factored that correctly because when I plug it back in, when I distribute it back out, I end up back with what I originally had. So this 3y times y plus 4 is the factored form of that expression. Now, factoring can be really hard. You have to be really good at finding factors, and sometimes you are going to face some confusing factorizations. So these examples have been so far, but factoring can be tricky because you have to figure out what got multiplied in the first place to produce the expression that you are given so that you can work your way backwards. Very much like trying to solve a puzzle or solve a mystery from the end and work your way backwards. Experience does help because you will start to notice patterns and some common factors. The more experience you get, the easier it does become. So let's take a look at this. 4x squared plus 9. It's hard to see that 2 there, but that is a squared. And you don't see any common factors. The factors of 4 are 1 and 4 and 2. And then there's these x times x. And then the factors of 9 are 1 and 9, 3 and 3. So I don't see any common factors, but there are some special tricks that can help us know how to factor some of these special binomials and special polynomials. And I'll be giving you a handout with all of those. But this one follows a special rule called the difference of squares. Difference of squares. And this is our difference of squares formula. A plus b times a minus b equals a squared minus b squared. Well, here we have our a squared minus b squared. So we're going to write that as a. Our a is 2x squared, because I know that if I squared that, I would get 4x squared. Minus, here's our b term, 3 squared, which gives me to 9. Once I know that, I can plug this back into my original equation here of a plus b and a plus b, where my a term is 2x, or sorry, a plus b and a minus b. My a term is 2x, and my b term is 3. Again, if I were to FOIL that back out, it would take me right back up to where I started, which is a sign that I did it correctly. Here are some identities that you're going to become familiar with. We've got the difference of squares, we've got the difference of cubes, and some other identities that you need to be familiar with as you're factoring. So I will give you those and make sure that you're able to use those as a reference tool. The factored form when we're trying to simplify something is usually the best. When trying to factor, follow these steps. First, factor out any common terms, any common factors. If they both have a factor of 2, take that out. If they both have a factor of x, factor that out. If they both have a factor of z, factor that out. What you don't want to factor out is a 1. You can, but it's not going to change anything. So look for the greatest common factor. You can look at an expression and see if it fits any of the identities, plus any more that you may know. That might give you some help in factoring. And then keep going until you can't factor anymore. Keep going until you can't factor anymore. Let's take a look at some examples. W to the 4th minus 16. Well, when I look at it, I don't see anything that looks like it can be factored. Nothing in common. But that 4 and that 16 kind of make me think of some patterns that I know. So I know that 4 squared is 16, and maybe that has something to do with 4 squared, or 2 to the 4th is 16. So we're going to keep these things in mind as we play around with this. So maybe we're looking for an exponent of 4, maybe we could try an exponent of 2. maybe we could write it this way. W squared to the second power, this is the same as, minus 4 squared. So I'm going to write both of those with the same exponent. Once they're both in a square term, this is just the difference of squares. A minus b times a plus b. And so you can see we've written that a plus b and a minus b are difference of squares. But then these look like maybe they can be factored again, specifically this one. That looks like another difference of squares. So we're going to factor that one again. W squared minus 4 is the same as adding this w squared plus 4 down here and factoring this using difference of squares to w plus 2 and w minus 2. Okay, first we're going to remove the common factor of 3u in this equation, or this expression right up here in the corner. When we've done that, we're left with u cubed minus 8u cubed in parentheses. I know that 8 is just 2 cubed, and I see all these other cubes, which tells me we're going to be using a difference of cubes. And in our difference of cubes, first we're going to write u cubed minus 2v cubed. So we're going to write that as an actual cubed expression. Using our rules in the handouts that I'm going to give you, we're going to write that as 3u, which was already here, times u minus 2v minus u squared plus 2u plus 4v squared. And that is a formula that you're just plugging your a and your b and your c expression into. Okay, what about this one? Try factoring the first two and second two separately. When we look at the first two, they have a z squared in common, which leaves me with 1z in the first one and 1 in the second one, because z squared times 1 is z squared. Over here, it looks like I can factor a 9, and when I do that, that's a z minus a 1. And you should notice a similarity here, a pattern. Because z minus 1 is on both sides, we can use that. And then z squared, what's left? Z squared minus 9 times z minus 1. Z squared is a difference of squares, and so we're going to factor that using our difference of squares for a final answer of z minus 3 times z plus 3 times z minus 1. If you guys have any questions, be sure to ask me. Next class, we'll be working on factoring, difference of squares, and some other factoring methods you can use over the next few days.